All right, if simple linear regression is computed between only two variables, when dependent variable is continuous and the dependent variable is categorical. Before going to next type of regression, many students asked how is this simple linear regression differ from an ANOVA, and that is a controversial question because same formula, same variables. All right. For ANOVA is primarily used to compare means between two or more groups. Okay, let's say it can compute means in male student and means in female student in their performance, right? Or in their in the parents' income, right? But for regression, it may seem similar but is different. For regression, we involve fitting a line or a curve to a set of data points to establish a predictive relationship, right? It is like drawing a line through a scatter plot to identify trends and forecast future outcomes. So mostly in figures, you will see clearly. For ANOVA, you can see a column chart showing means through each group, or it is a line but just showing the means. But for regression or correlation, you will always see a positive or a negative line. So that line, we are seeing or we are checking if data are fitting on that line, how far data are closer to that line to predict the outcome we want. All right, that's it. Let's continue to a second type of regression, which is multiple linear regression. It's a multiple, not simple. Multiple, why? Because for, let's say for the formula, for the formula we have same function, LM, linear model, same dependent variable, which should be continuous data, and independent variables, which may be continuous and categorical. We see them, but more than one. We have x1, we have a plus, x2 plus, x3, etc. Right? Then our data, which is your data name. Okay. All right. As you can see, for predictors, we have more than one. Okay. That is multiple linear regression. Let's go and use our data to visualize it. We have LM, you have performance, and then till the where let's say gender, as we use there, plus let's see another variable there, We have gender here, we have accommodation, boarding and day school. You can use this one. Accommodation. Yep. And we can put more. We still have like grade, this combination, or school type, urban and rural. You can put whatever you want, but let me to here and put data. Our data is just data new. All right. Now we can run this. We can summarize. Summary of multiple linear regression. Here we are. We have this data. Now, what I said that this multiple linear regression is robust because it can even include continuous data in predictors. I was meaning like here we can see performance filled with income plus other variables, which these were independent variables. Remember, our income in ANOVA, our income is dependent variable because it's continuous data, or same thing as the performance and the gender, accommodation, grade, urban, well, independent variables. Now here, income can serve as a predictor to what? To performance or vice versa. And just compute your multiple regression analysis. In a summary, we can use one dependent variable, which is continuous, and more than one predictors, and these predictors can be continuous and categorical. That's it. All right. Let's include this income and DC and summary. Here we have now. Let's clearly show how to interpret this data. All right. What we have here, we have our formula call formula LM formula performance trade with income plus gender plus accommodation, and our data is data new. Okay, the first thing we have is residuals. Residuals we have time to discuss more in detail, but it shows the mean, the first quartile, the median, the third quartile, and the maximum. Okay. We can see down there residual standard error is 10%. This indicating the type size of the residuals. We have multiple R squared of 0.25. This indicates the approximately 25% of the variance in performance is explained by the model. Okay. Then adjusted R square, which is 0.22, which adjusts for the number of prediction in the model. And finally, we have F statistics, which is 7.7 with a p-value of 0.00015. Okay, this indicates that the model is a whole statistically significant, very high statistical significance. Now we can go to significance difference, the meaning of this star. If there is a 3 stars, it shows a very high statistical significance. If it is 2 stars, it shows a high statistical significance. If it is 1 star, it shows a statistical significance. All right. So now let's go to our coefficient. We have estimate, we have standard error, we have t-value, we have probability value. Okay. Now intercept. Intercept, you have seen that we have now in our variable how many predictors we have? We have 3. We have income, we have gender, and you have accommodation. Okay, we have 3 predictors of performance. All right. Now here we have income, gender, and accommodation. Now see clearly, gender has M, which means male student. Accommodation has day, which means day school. So what we don't see is female student and boarding schools, right? So now here how we interpret these results. You see estimate on intercept 34%. 34% score is held by a female student from boarding school. It means female students from boarding school have been taken as a difference to the model and got 34 score percent. All right. And from other predictors, you can add or remove the scores. It means for income, all right, because income was just single, not a category, we have 0.001. What does that mean? It means for every unit increase in income, performance is expected to increase by 0.0019 units, holding gender and accommodation constant. This effect is statistically significant. You see, is star. Okay, now let's go to income. Significance is this one. Okay, significance is this one. All right, let's go to gender. Gender has 3 units, but this is M. All right. So for gender, male, the coefficient for gender M3 represents the difference in performance between male and the female student, holding income and accommodation constant. Male students are expected to perform 3 units higher than female student on average. Okay, however, this difference is not statistically significant. As you can see, there is no star here. Okay. All right. So it means if a female student gets 34, a male student should get 34 plus 3. Okay. Now, let's go to accommodation. Accommodation for day school. The coefficient for accommodation day, which is -7, indicates that students in day schools are expected to perform 7.3 units lower than students in boarding school, holding income and gender constant. This effect is statistically significant, as you can see. So it means if a student goes 34, or let's say a student from boarding school got 34. Someone from day school should have 34 minus 7. It means 27%. Okay, this is how we clearly interpret the regression analysis results. We see which variable was not come up, and that is a reference, and we add or remove according to the statistics have gotten. All right. All right, in next video, we'll see another type of regression analysis.